Hello all. Now we will discuss the fundamental steps in a digital image processing. In the last class, we have seen why digital image processing is required to us. Suppose if we go for processing of any digital images, we should follow some of the following steps. Initially, if you want to process any image, you should have an image, right? So, the step which is going to capture the image by any physical device is image acquisition. To put it in a simple way, image acquisition is just taking an image and transferring into a system. When you take an image, you are very much clear that what is the problem domain you should be having while you start processing it. For example, if you have been taking a medical image, it's very much clear that you are analyzing a medical image and you are interpreting it the same. The same way, if you are capturing an image of your friend, you have been very much clear that you might increase the contrast or reduce the contrast. Somehow you make sure that your friend's image looks good for you. So your problem domain is very much clear when you start acquiring an image. Basically, how you are going to acquire an image? A light focus falls on the image or falls also on the object, and the object starts reflecting it, and the reflected radiations have been captured by the camera, and due to that, due to the sensors available in the camera, you are going to acquire the image. So the first fundamental step is image acquisition with a problem domain in our minds. After you acquire image, you go for image filtering and enhancement. So after image acquisition, you go for image filtering and enhancement. In image filtering and enhancement, you are going to increase the quality of the image as a whole. Why we are supposed to increase the quality of the image? Quality of the image is important to us because we are supposed to make sure our image looks good enough visually. You have a numerous set of enhancement techniques available, but they are not the standardized. I meant to say is, for enhancing X-ray images is totally different from enhancing a remote sensing images. Therefore, remote sensing images as well as X-ray images might have their own enhancement techniques, but they do follow enhancement techniques, which is important part of image processing. Image enhancement sometimes happens with a specific part of an image. If you have been concentrating on an image which will be having a lots of parts in it. For example, for a forensic department. In a forensic department, your CCTV camera is going to capture an image. In that image, any one particular part where suspicion is going to happen, you are going to observe it. That suspicious movements can be enhanced and observed what actually is happening in that image. Similarly, after image enhancement, we go for image restoration. Image restoration is usually done for degraded images or damaged images. Degraded images might have lost the content of the image. In order to recover that lost content, we go for image restoration. In image restoration should happen means the image should be degraded. What are the reasons why the images do get degraded? Namely, motion blur. Motion blur is one of the reasons where degradation of the images do happen. Like, you have been sitting in a train and the train is moving at particular speed. If you want to capture a monument which is stagnant at one particular position and you are moving, if you capture an image, that image is usually blurred. So that is one of the way how images get degraded. One more is a simple blur. you're taking an image of your friend, and if you are shaking the camera and you are not properly making the camera to stand in one particular position, obviously your images do get blurred. Such type of images are also not visually pleasurable. So we go for image restoration. So blurring is one of the reasons why degradation of the images do happen. Third important reason why degradation do happen is noise. Noise do occur in our images when we capture it. So image restoration is required when a noise is being added. While discussing the introduction for the subject, there we have given you an example of how different is a noisy image and a noiseless image. And one more reason why image restoration is required, the degradation do happen, is camera defocus. If you are not able to focus the camera properly, or due to the movement of the lens, if the lens is not properly placed, the motion of due to the camera movements or due to the lenses not being properly placed, the camera defocus do happen and images get degraded, and image restoration is required. In these four cases, how image restoration is being done? There are two ways how image restoration is happening. One is inverse filtering and another one is deconvolution. In inverse filtering, you are very much clear that why the image is being degraded. For example, you are very much sure that this is the reason why the image is being degraded. We need to restore that image. When you know the process how it has happened, if you just follow the inverse of it, you can get the restored images. Whereas in deconvolution method, you do not know how the degradation of the images has happened. At that part of time also, you can go for image restoration and you can get a proper images of your requirement. Next, color enhancement, where we involve color image processing. With the rapid growth of internet nowadays, color image processing has become very important, because each and every image which we take nowadays need to be put up in a Facebook, Instagram, WhatsApp and many more socially available networks. So color image processing has gained its speed with the rise of internet. The next fundamental step is wavelet and multi-resolution. Wavelets are the foundation for representing the images in different degrees of resolution. One image if you take, you can break the image or you can divide the image with a different resolutions. For example, in a one particular image, if an image of a hair of a person is very high resoluted, you can pick up that part and make your study if you are interested in that region of interest. One more important fundamental step in image processing is image compression. With the increased usage of internet and broadband applications, images do transfer from one place to another. Before transferring of images, we make sure that it does not use the heavier bandwidth. So we go for image compression. In image compression, we usually remove off the redundancy parts of the image, so that if I remove the redundancy contents of the image or the redundancy in the images, then the compressed image whatever you are going to get looks very similar to that of your previous image. because you have just removed the redundancies. You have been kept the significant part as they are. In image compression, reduction happens lossy or lossless way. We call it as a lossy compression or a lossless compression. In a lossy compression, we are going to lose some of the contents of the image which are part of the image. That is compromisable when you are going to upload an image to a Facebook, WhatsApp, Instagram or any other social media. Lossy images are comfortable, or we can compromise with that when we are going to upload our images to a Facebook, WhatsApp, Instagram or any other social media when it is with respect to lossy images. Whereas when we go for medical image compression, we do not go for lossy image compression while we go for lossless image compression, because each and every content in a medical image is important for the doctors for analysis of the disease or any other purpose. We have morphological processing. In morphological processing, we are going to extract the image contents that will help for representation and description of the image. Suppose if you have taken an image of a dog. In that, if you want to concentrate on the eyes of the dog, you can extract that image content which will help you for representing and description of that eye of a dog. There, morphological processing is required. Next fundamental step is segmentation. Segmentation is one of the difficult tasks in image processing, because in segmentation we partition the image such a way that whichever part of the image is important to us, we are going to segment it and we are going to pick it up. After we pick it up, we put a proper threshold to it and observe the images. Once I start the PPT of the fundamental steps in digital image processing, then I can show you how clearly segmentation is important. Next, representation and description. Before I put a light on representation, let me discuss about description. Description, also called as feature selection. Here we extract the image attributes which will in turn help us to understand the quantitative information of that image. Similarly, in a representation, we are going to represent any one particular part of the image with respect to the boundary or with respect to the region. We'll give an example for this. You have two ways of representation. One is with respect to the boundary and one more is with respect to the region representation. If you take an Asia map, if you want to pick it up only the Indian region, Indian country, you can go for boundary representation, which will help you to detect the country India. Similarly, you can in India, which of the 4 regions if you are been interested, like North India, South India, then you go for regional representation. So in this way, this is one of the steps in fundamental digital image processing steps. In this way, representation and description has become one of the important steps in digital image processing. And finally, object recognition. As the name itself suggests, if an image is being given to you, you are going to identify the objects which are present there. Like, if you take an image of your classroom, what all the objects that does your program is going to detect? It might be a chairs, it might be a duster, it might be a student sitting on the chair, all the objects which are there in the classroom can be recognized using digital image processing steps. So, all these have been connected to a central unit where the actual algorithms, all the processings, all the knowledge base is being put up. So, that is knowledge base. So, image acquisition, we need a knowledge base for that. Similarly, for image filtering and enhancement, image restoration, color image processing, wavelets and resolution. We'll put more light on this when I start the PPT presentation for you. Image compression, morphological processing, segmentation, representation and recognition, finally object recognition. So, in this way your fundamental steps in digital image processing is being designed. Wherever I put a tick mark like image acquisition, image filtering and enhancement, image restoration, color image processing, wavelets and resolution, image compression, the outputs of these are usually images, whereas morphological processing, segmentation, representation and description, object recognition, the outputs of these are usually image attributes. So, with these basic steps in understanding digital image processing, we will go ahead with the components. What are the components we need for understanding the digital image processing much more way? So, next we will start with the PPT presentation, where I will show you with respect to the images. With respect to the images, I will explain the steps. So, that will be much more clear for you. Fine? We will go for the PPT presentation. So, we discussed the fundamental steps in a digital image processing on a blackboard representation. Now, with respect to images, we will be much more having a clarity of how these steps will be carried out. Have a look of the fundamental steps here. So, you know that first step is image acquisition. Yes, this is a step where we are going to acquire the image from the user. This image acquisition will be done by any physical device like a cameras. And while we capturing the image itself, we will be very much sure that what is our problem domain, what we have to do with this image. With that intention, we will start our fundamental steps. And next we have image enhancement. As we have discussed, there we are going to increase the quality of the image. Next we have image restoration. Any image which has been degraded, we will go for improvising, or we will restore that image. Color image processing, because of the rising of internet broadband technologies, we are supposed to cope up with that. So we go for processing the color images as well. Next we have wavelets and multi-resolution. This is a foundation for breaking an image into different resolutions, wavelets. Next, image compression for transfer of the images from one device to other device, for the transmission of the device over the internet. We have two methods there, lossy, lossless, both we have discussed. Next, morphological processing. Any area of interest, we are going to retrieve that. Segmentation, we are going to break the image, and whichever the image has an important part within that, we are going to pick it up, we will apply the primitive method of thresholding, and we will start studying there. Representation and description, feature selection, it is going to give you the idea of the features in an image. Representation, boundary representation, region representation, finally object recognition. So with respect to images, let me put a light on this. So image acquisition, there will be a light source which is going to project on an object. object is going to reflect that image. The object is going to actually reflect the radiations. Those radiations are captured in a camera. A camera has a sensors. It is going to capture the image and it is going to get a digitizer. Using digitizer, it is going to convert into a digital image. So here the actual acquisition of the images do happen. Next, after the acquisition of the images, internally sampling and quantization do happen. We will see in further classes how the sampling and quantization do happen. And we get a digitized image. This is our task now. So during this process, what all the steps we will see now. Next, image enhancement. If an image is not enhanced, how does it look? It looks something like this. There is a loss in the brightness. There is a no proper contrast. Such type of images, when we go for image enhancement, when we increase the contrast, when we increase the brightness, we will be able to see clearly the image. When we see the images very clearly, it is always a positive pointer to us such the way that we can identify what has happening in the image. What is this boxes? What is this building? What are the cars? We can see where the road is present. It's very clearly we can analyze the image. Therefore, image enhancement is one of the important tasks here. Next, image restoration. Now see, this image has been degraded. There is a lot of pixels, noises, blur of the image. When I go for restoration of the image, it looks something like this. Yes, the image is being restored. Now you see, in this image, can you see a person who is standing here? No, you cannot see it. You should concentrate on this image and see. Now if you concentrate, here is the image. Here is the person who is being present in the image. But if we go for image restoration, so directly you can see a person being standing here. So in this way, image restoration is one of the important steps in digital image processing. Next, color image compressions we will see, image compressions also we will see. With respect to morphological processing we will see. But how about this one? Observe, this is with respect to wavelets and multi-resolution. Here I am going to increase the resolution of the image. See, on the head of the person you are able to see the pixels. The pixels are, using the pixels there is a triangle be formed. Now how I can increase the resolution of this image? I am going to select the center point in this triangle and I am going to join with other pixels. When I do this, number of pixels increases. When a number of pixels increases, obviously the resolution of the image increases. This is done in multi-resolution step. Here, this image is showing up actually the compressed image. This is the original image and this is the compressed image. Are you able to find any difference? No, because there is no loss in the content of the image. Only the redundancy is being removed. Where the redundancy occurs, the redundancy might be somewhere here, a green part, okay, where a continuous pixels and its neighbor pixels are same enough. We can remove off that. It is not going to affect the image. So in this way, image compression is one of the steps in digital image processing where we will reduce the size of the image and help for transferring of the images. Next, morphology. In morphological, you have four operations, basic operations. One is erosion, dilation, opening and closing. So morphological operations we will study in a depth in the coming modules. As of now, you understand is morphology is going to extract the quantitative information from the device, from the image, sorry. This is your segmentation. Now see, left side you are able to see an image. In this image there are some set of dots. I want to extract that part and I need to go for a study of that. That means I need to break that part of an image and I need to increase the threshold of it. I need to study for that. Then here we go for segmentation. In segmentation, I can identify the boundaries of this. Okay. So after that, I'm going to increase the resolution. Okay. So here actually the spatial filtering, smoothing filtering, lots of techniques do happen, but segmentation is the major task is happening here. So this segmentation will help us for extracting the important part of the image and go for study of that images. In this way, your segmentation is becoming one of the difficult tasks but also one of the important tasks in image processing. So this is with respect to representation and description of the image. See, representation, you are able to see the what is the description. It is a feature, it's just a image. Okay, so we can extract the features of here. We can also represent it. For representation, he is taking a digitized image. This common part is being put up onto a grid enough that will help me for further analysis. Finally, object recognition. So this is the image of one room. So when you start programming your device, when you start programming your image processing system, it will start it should identify objects. Okay, this is a laptop, the blue box. It's a laptop. It's a glass being placed. We are able to recognize. But if a system starts recognizing an object, that is always a positive end for us. Therefore, the fundamental steps which we discussed now are very important in a coming course of the subject. The next classes onwards, we will start with the components of image processing. Thank you. If you have any queries, let me know.